No, I did.
Welcome, Algebra. Today we have a lesson on graphing linear equations, and we're going to start chapter 3. I know you're excited. You excited? Yeah. Show their excitement. Yes. And I know you at home are excited also. We're going to do this a little bit, so if you're reading the chapter, that's fine. But I have to say I'm going to skip part 1, because part 1, I don't know, these guys really did not enjoy it. They didn't enjoy standard form. Ben Douglas, this is for you. This is a shout out to you. 2 years ago, I know you hated standard form. And we're just, honestly, standard form is better used later on. So we're going to skip that section. And we're going to just go, in your book, it's part 2. What page would that be on? Page 157. And it's on basically how to graph a line. And when I say graph, I mean like, a coordinate graph like this. So if they give you an equation that's going to make a line, if you think about it, most of the time, it's going to cross both the x and the y axis. Do you agree? Yes. And when it does, there's a certain place where it crosses the x-axis, and we call that the x-intercept. And there's a certain place where we cross the y-axis, and that's called the y-intercept. Okay? So there's a little bit of terminology that I just want you to understand, so as we go through this. Now, maybe I should start with, why do we graph at all? Like, why is there this graph? And I don't know what this line is kind of complicated. It might be something like y equals the opposite of x plus 7/2. Let's just pretend it was that. Now, let me ask you, you student audience here, how many x and y's could make this equation true if you just looked at it? Yes, young lady in the back? A lot, she says. And if you think about it, that's right. There are an infinite number of x and y's, if I plug them in here, that can make this true. If I plugged 1 in for x, then y would be 5/2. Right? That would work. If I plugged 2 in for x, then y would be 3/2. So anyway, there are an infinite number of coordinate points that would fall on this line. That's what I'm trying to say. No, I'm not saying every point would fall on that line. Like, for instance, if you picked 0, 0, that's not on the line. And also, if I stick 0 in here for x, and I stick 0 in for y, it does not work. So, basically what I'm saying is, if I gave you an equation, and I asked you to list every x and y that made this true, you would be at this for eternity. You could never list all the coordinate points that make it true. So therefore, we use a graph. And the graph is basically just showing you every single infinite point that can make that equation true. Does that make sense at home? Good. That's why we have arrows on it, because it goes on forever in every direction. So right now, graphing I know is a little unfamiliar to you. Graphing is just a way of doing things that we can't do by listing numbers in algebra. Alright, now, right now you don't know how to graph, and so the way that I'm going to teach you is 2 different ways. One is called making a graph by using the x and y intercepts. That's why I needed you to know those terms. And one is called making a graph by making a table. So both of them are going to go like this. Let's just say that we had a graph like y equals x plus 1. So if you wanted to know the x and y intercepts, if you think about it, where something is crossing the x-axis, the y, in other words, how far above or below that line, is always going to be 0, right? So if you want the x-intercept, you just put in 0 for y, and then solve it. So 0 equals x plus 1, take away the 1, x equals -1. If you want to know the y-intercept the y-intercept is going to be where it falls on this line. And if you think about it, the x in that case is also going to be 0. It's going to be neither to the right or left. It's going to be right on the 0. So if I want the y-intercept, I put it in as 0. Put in 0 here, solve it, and y equals 1. Hopefully that makes sense at home. So this is a method, this is called graphing it by finding the two intercepts. So I just simply put this in, go -1 up 0, and I go 0 and up 1. Get rid of that. And I draw a line between those 2 points, and that is my new line that I was trying to graph. So that's graphing it by finding the intercepts. The other way to do it is, there's a million other points you could have, so you don't have to pick the y-intercepts. What if you just did a table? So you put an x and a y, and you can just pick anything here for x. If it's y equals something, I'm going to choose things for x. If it's x equals something, I'm going to choose some things for y. So in this case, I'm just going to choose -1, 0, 1. Stick in -1 here, and you can see that y is going to be 0. Stick in 0 there, y is going to be 1. Stick in 1 there, you can see y is going to be 2. Now if I graph that, you can see it's going to be the same line, but I'll do it. -1, 0, 0 up 1, over 1 up 2. That's going to give you the same line that we had before. Okay, does that make sense? So there's two main things I want you to get out of this lesson. One is why we make a graph at all. And the reason why we make a graph at all is because it's showing all the possible x and y's that make this equation true. And the second thing I want to get you to get out of this lesson is the way you would make a graph right now, until you learn other methods, is by either making a table and just sticking in some numbers and figuring out what the corresponding number would be, or you can find the two intercepts and draw a line between those. Okay? All right, I'm out.